Welcome back to the Heights of Humanity podcast. In this episode, I sat down with Shubham Pandey, a data scientist who specializes in building machine learning algorithms in both the advertising and finance industries. Shubham presented some truly amazing insights into the impact and future of artificial intelligence that I have not heard anywhere else. As always, I hope you learned something from this episode, and I wish you all the best. Now, without further ado. Okay, Shubham, thanks so much for coming out. How are you doing? How's your day going?
I mean, I just woke up and I think it's a great start to my day.
Mhm.
Being here, like starting my weekend.
Mhm.
So, yeah.
What do you think of the weather lately? It's been frigid.
Yeah, it's just been swinging like a pendulum, I guess.
Mm-hmm.
Going below freezing and then just warm.
Yeah.
It's weird.
Yeah. Now, how's your work going? Everything?
Yeah, everything is going good.
Mhm.
Getting a lot of challenging problems.
Mhm.
So that's something that I'm excited about working on. Yeah,
Very cool.
it's good.
Very cool.
Yeah.
Can you summarize your work in your field for us, for those not super familiar with
Yeah.
data analytics and things?
Yeah, definitely. So, I mean, my background has mainly been in various aspects of optimization.
Mm-hmm.
So, dealing with lots of data. And in the recent past, you have seen that, the amount of data that every business has to deal with has grown by a huge amount. And when I say huge amount of data, it's just not about storage.
Mm-hmm.
You are not only concerned about storing the data and just retrieving it in plain form, but you do want to study it and you want to get useful insights out of it. Right?
Mm-hmm.
And that's exactly what data science is, because science is studying something, and so data science is studying data, right?
Mm-hmm.
And if you talk about software development, that's also like, building something out of, building something on top of that so that users are able to benefit from it.
Mm-hmm.
So, yeah, I mean, software development has faced many challenges because of the growing data.
Yep.
And my experience has mainly been in building those applications that are powered by, huge amounts of data.
Yeah. Yeah. So what has that change been like? Is every year, is there more and more data that's kind of available to your industry?
Yeah, exactly. So if you go 2 decades back, right, organizations, they used to store data on premise. And when I say on premise, it's like a term that we use to say that they are storing data on the physical machines that they have, that they own, right?
So on the computers that they own, like at their facility.
Exactly. The
Okay.
storage systems, and then they would have, and this is 2 decades back, and they would have people, like some database experts, managing it.
Mm-hmm.
But a few years later, it's just like people started to have a lot of online presence, and although it became easier for the consumers to find products, it became a big challenge for the business to
Gotcha.
digitize themselves, right?
Mm-hmm.
So, yeah, I mean, it's the 5 V's of big data, right? So one of them is volume.
Okay.
Right? So it has started to grow a lot, and also with a great velocity.
Mm-hmm.
So it's a big challenge for sure.
What are the other V's that you talk about? The 5 V's.
Yeah, let me try to recall.
So yeah, no problem.
Yeah, it's volume, velocity, variety.
Mm-hmm.
Variety is important because you see data in a lot of different forms. And then they have veracity, which is to make sure that data is legit. Like, you need to go through all of those processes where you say, okay, this data is legit and this data is not.
Mm-hmm.
And then there's value.
Value. Okay.
So how much is this piece of data going to bring value to business?
Gotcha.
So, yeah.
And how do you look at those 5 V's? Or is that something that so say there's like a data product and you're looking at, how can we use this? Are you checking off like, okay, it's got a lot of volume, but it doesn't have a lot of velocity, but it has a lot of variety. Are you kind of looking at it like that?
So I think all of these V's, they manifest themselves naturally.
Okay.
So it's just that how is business looking at it? So some of the V's in here are going to pose a big challenge to the business, for example, velocity and volume and variety, right? Because if you have lots of different types of data, then you have to think about what kind of underlying databases do you want to use to store them. And velocity is, of course, a problem because your systems have to be capable enough to kind of ingest all of that data with that speed, right? And then volume, of course. if there's lots of data that you have to deal with, then of course you cannot have on-premise machines. It's just a huge headache for all the businesses to have those machines and have the database experts managing it, which is the reason why you'd see the advent of the cloud technologies, because there's just only a few businesses who are going to provide that service to you to store that huge amount of data and just manage it.
Yeah. And how recent is that big switch from storing data physically to storing things on the cloud?
It is, so like I said, 2 decades back, people did not usually think about it. Actually, more than 2 decades back now. But as soon as people started to have their online presence, the amount of data started to grow drastically. So that is when businesses had to transition into using those cloud technologies, because it was just not feasible for them to have those database experts, to hire those people and do it themselves.
Yeah, you can only build a computer so big that can store so many things, right?
So there's one thing called vertical scaling and there's one thing called horizontal scaling. And vertical scaling is when you keep upgrading a machine. Let's just say that you have a machine that has, 16 gigs of RAM or 32 gigs of RAM, like you have in your personal computers, right? But if you want to upgrade that machine in terms of storage or memory, there's a limit that you would reach, beyond which you have just reached state of the art. You cannot scale it beyond that. That's called vertical scaling. And what we usually do when we want to deal with huge amounts of data is we horizontally scale. Instead of upgrading a single machine, what we do is we introduce a lot of machines and we just distribute the loads.
Gotcha.
So yeah, that's how you deal with huge amounts of data. It's just not a single machine doing everything, of course.
So if I'm getting this right, vertical scaling is upgrading the individual machine, and horizontal scaling is, I'm at the same level of efficiency, but I'm just having more and more machines at this level to make everything faster and more efficient.
Yeah, and in fact, you'd be surprised that the horizontal scaling option is actually very cost effective, because scaling a machine vertically is, you can imagine, right? If you're buying a MacBook that has a higher RAM, it's going to cost you significantly. But if you have like many machines that have just, a small amount of RAM, and if you are able to find a way to distribute the load, then you'd find that option much cheaper. Otherwise, you'd end up having a supercomputer and it's still not going to, do the job for you.
Yeah.
So
does that, I'm pretty ignorant about the subject, but I'm almost thinking that might get in the way of innovation in regards to making the individual product better, if instead of making the machine itself incrementally better, you're scaling horizontally, like you said. So now you just have a lot of machines we have this problem that requires this much computing power. Okay, we're going to buy all these machines instead of improving our computer.
Interesting point. So you'd be surprised to know how almost every business is fine with doing horizontal scaling, and only a few research works would really need a vertical scaling, because every problem can be solved. Most of the business's problems can be solved with distributing their load to multiple machines. You can imagine, like, for example, Amazon, right? There's lots of people purchasing things on Amazon. Now, why do you want all of the traffic from every user in the world to go to a single machine? It can be distributed, right? So there's a machine that's going to distribute the load to every machine, and they would take care of it. So before you say, it limits the capacity to innovate, let's ask ourselves a question: that do we really need a machine that is that powerful, and do we want that machine to be only responsible for computing everything, right? So unless you're computing, billion digits of pi after the decimal places, you would probably not need a supercomputer, right? So that's the reason why supercomputers are extremely vertically scaled, is because they are doing a very specific niche job that's just very specific to some research work. So I would say, it's always good to vertically scale, but you'd be surprised to see that almost, 99.99% of the businesses, it's just horizontal scaling.
Yeah, it's just more efficient and probably more time and cost effective.
Yeah. And you can just bring a machine up or bring the machine down based on the traffic that you have throughout the day, or based on the season.
Mm-hmm.
So
So talk to me a little bit about your journey up to this point. How did you end up being a data scientist in Austin?
okay, so yeah, that's an interesting journey. I mean, I, I can probably trace it back to my high school. So I took a C++ course, and I was just interested with. I just got interested in writing programs, and so I think it was just really exciting to write code and just write everything that you want and then make computer do it. Right? It just feels good, and also like the way computer science is closely related to maths, because I was always interested in maths. So you know I started to like computer science, and also it's a field that's in demand today.
Mm-hmm.
So it was a no-brainer for me to pursue this field. And I think with my experiences back in India, like I worked in India full time for 3 years. I just realized that data is something that I really like, getting useful insights out of it, and also just optimizing things, because it's a big challenge for all the businesses now.
Mm-hmm.
So that's how that has been my journey, and yeah, that's the reason why I just really like dealing with a lot of data.
Mm-hmm.
Um, yeah, I mean, optimization is my thing. I just love that. I did my master's at Purdue, and then I focused on all the topics related to dealing with data, and yeah, that brings me here.
Mm-hmm. What was that journey like going from India to the US?
Yeah, I mean, there's many aspects to it, honestly. Like the feeling is like, I don't know, you maybe uninstall an app and then reinstall it, and you have to start over again. I don't know, but yeah, I mean, change of environment was definitely. I mean, I had to get accustomed to a lot of things, like, um, of course, the weather, especially in India, and it's
Oh,
pretty
yeah.
chilly,
Yeah.
right? And then also I guess the medical system here is like a lot different from how it is in India. So I had to understand, what's copay, what's deductible, and all of that. I was not aware of all of those things. Uh, yeah, I mean, so many different things. Like people here love to commute, like drive a lot. In India, people would definitely prefer, flying or taking a train. But yeah, people here drive long distances. So like lot of different things that I realized was very different from India. But yeah, I mean, I think overall the transition was pretty good.
Mm-hmm.
I'm liking it here, so yeah.
Yeah. Yeah. Do you like the weather better here or
Oh,
better there, or do you not
interesting.
have an opinion?
I definitely like colder weather, but not the kind of extremes that I saw in Indiana.
Okay.
But I just don't like too much heat, because I guess I have been in parts of India where the heat would go to around 42 degrees Celsius.
Mm-hmm.
That's way above 100, I guess.
Yeah. Yeah.
Yeah,
That's
100 Fahrenheit.
yeah.
That's bad.
That's pretty bad.
Yeah.
All right. So what about? So you're talking about differences between India and the U.S. As far as industry goes, and working in India and working in the U.S. What are some of the different things that the companies do in the U.S. that they don't do in India?
Hmm. That's a hard question, because hmm, the thing is, when I was working in India, it was like I was still working with a multinational corporation, right? I worked with Goldman Sachs and Visa, and I used to interact with people from across the globe.
Gotcha. Okay.
Like I worked with folks from
Yeah.
Singapore, London, US.
Mm-hmm.
Yeah. So I don't think there's a big difference.
So it's always
Especially
been
if
very international.
Yeah.
Gotcha.
It's just I mean, it just depends on the company culture, as opposed to being in India or being in the US.
Mm-hmm.
But yeah, I think the small thing that I noticed was people in the US, they don't mind waking up at 8 a.m. Most of them. I'm not generalizing either for the people in the US or India or in India, but yeah, I find it hard to do.
Gotcha.
Yeah.
Yeah. Sorry to make you wake up early for the
Oh,
podcast.
no, that's fine. I mean, 9 a.m. is fine.
Okay. Okay. Cool. So 8 a.m. is no good, but after 9 a.m.
Yeah,
you're all good.
yeah.
Okay. So um, switching to AI and machine learning, what makes AI and machine learning and deep learning and all those things so powerful?
Okay, so I think I can speak about it in terms of the kind of work that we are doing, right?
Mm-hmm.
Let's just, and I probably will touch some of the fundamentals here. Uh, so what we are trying to do is we are trying to reach the audience that might be. I'm just giving an example here, right? Our business problem is we are trying to reach the audience um, that may be interested in a product or a service, right? So let's just think about all the products and services out there. There are millions or perhaps billions of products, right? So the problem of identifying that this product might be useful to this audience. Let's just say that you're writing, you think of writing a piece of code, and it's rule based, right? So when I say rule based, what is it? It's just you are trying to identify some parameters and saying if this value is equal to this, then product equal to this, something like that, right?
Okay.
So you can imagine how laborious that would be, and you'd end up writing that piece of code for your lifetime, and even then you would not be able to cover all the products, right? So that's a hard problem to solve, and that's where we resort to using those sophisticated machine learning algorithms that are informed by the historical data of success and also like many different parameters. So they learn all of those parameters, and then they are able to suggest that this is the great opportunity, this audience might be interested in these kind of products. And it's still not a binary decision. It's not that okay, you found an opportunity and you just want to place that product. When we are doing that, there has to be a dollar value associated with it. Okay, so because you kind of bid, you are saying that okay, I want to place my ad on this website, and this is the dollar value that I'm willing to give, right? So and then there's an auction that's conducted, and whoever wins the bid is gonna get their ad placed there. So that's another caveat to it, deciding which product and then deciding the dollar value. And the story still doesn't end there, because as a business, if you want to reach different audience, you have a budget, right? So let's just say that you want to sell something during holidays, right? And you have a specific budget. So so you've written an algorithm that's really smart, right? Able to reach all the right audiences, and it's able to predict the right dollar value to win the bid, but it ends up consuming all your budget in 2 days, and you could not even get close to maybe Christmas, and you ended up spending all your budget, right? So that's bad. So there's another problem to solve, which is to be very cognizant about the remaining budget. And so all of these three things, if you want to keep all of these three things in mind, then you can see how AI can be useful in not just predicting the opportunities and not just predicting the dollar value, but also understanding this is how I want to span the usage of my budget.
Mm-hmm.
Right? So it is a complicated problem, and that's the reason why we use all of those machine learning algorithms
Gotcha.
to help us out.
When you say budget, do you mean the company's budget or the budget of the person trying to get their advertisements out there?
The person who's trying to get their advertisements out.
Gotcha.
That's
So if I'm running an ad campaign at the beginning of the month, like you were saying, and then I want to maybe hype things up for Christmas, and normally before AI, you would have people writing code saying, if this person likes gym equipment, or like if this person likes gym post, then show them gym equipment ads, right? But to find every parameter and every category and then to find every ad to show is a huge problem. It's going to cost a lot of money for the person trying to advertise, right? So then you use AI to speed the whole process up, and it's able to work really quickly with all this big data, and then also take into account the amount of money or the amount of capital you have going into that advertising campaign. Is that a good summary?
Yeah, just a quick clarification on the first part. I think we touched upon the rule-based code, right? So it was just an example to actually contrast the benefit that AI would give you, but people, like in the history of the world, people would never write rule-based code for this problem. what they would normally do before AI or before all of these machine learning algorithms came into picture is they would do some market research, right? They would still study the data. So data science was naturally there forever, right? People are studying data, but they would not. They would just not have those machine learning algorithms to do it for them and really fast. Because you can imagine when you are loading a web page, right? How fast is it? How fast is it able to load that page? So before it shows you all the data and maybe possibly some ads, everything has already happened, including the auction and deciding who won the bid,
Wow.
and then show the ad to you, right? So you can imagine how fast we need to be,
Mm-hmm.
especially in the inference times. So there's two aspects to machine learning algorithm, right? One is how fast are you able to train it, and then how fast is that machine learning algorithm going to do the predictions for you or do the inferences for you.
Okay.
So we have to optimize both of these things, but especially the second part.
Okay, back at it. Can you define inference time for me?
Yeah. So there are two aspects to machine learning algorithms, like I mentioned, right? Is how much time does an algorithm take to train? That's when it's going to optimize all of its parameters, and it's just going to learn everything. And then there's the whole point of making a machine learning algorithm learn is because it would be able to do something for you, right? So that do something part is actually inferences. So once it is trained, now in the real world, it is going to see some parameters, some values come in, and it's going to do its job of giving some output, right? Let's just say an image recognition algorithm, machine learning algorithm, it was trained to identify animals, right? So you trained it, fine, maybe it took 2 or 3 days. Now, what's more important is, actually they are equally important, but what's really important is when you give a new image to that machine learning algorithm, how long does it take to give you the answer, right? So that's inference times.
Gotcha. So how fast are inference times becoming nowadays?
It honestly, it depends on domains.
Mm-hmm.
But what I can say is many deep learning or neural network based architectures, they tend to have a higher um, inference times as opposed to some simpler algorithms like, I don't know, decision tree, because it's just going to make some decisions to a certain depth and then give you the answer. So if I had to, I don't think I can pick a number and answer that question. It's just it just depends on time. You can ask that question to yourself and actually get the answer, right? So let's say you want to search an image on Google, right? Google allows you to do that. So if you just input that image in the search box, how long does it take to give you all of those results, right? That's inference time.
Gotcha. Okay.
But it's at a very large scale because it's gonna give you a lot of images, right?
Mm-hmm.
But and that's commendable, by the way. It's really fast.
Mm-hmm.
But yeah, I mean, you can see all of those inference times in many applications.
Mm.
It can just vary. It can be, I don't know, a minute. Some machine learning algorithm can be so sophisticated, and for a very hard problem, they could take a minute, an hour, I don't know. Or it can be microseconds, nanoseconds.
Mm-hmm.
It just depends.
Gotcha. Just depends on how much you're putting into it, and then, like you said, like the decision-making process.
The decision-making process is actually a very important factor, because neural network architecture, let's just say it's a deep neural network, right? So naturally, it's going to take time because the data has to be passed on to many different layers, and then eventually it would predict the output. And that's one of the reasons why you'd see that in many low latency domains, where you have to like make a decision really fast, they would probably not use a neural network architecture, even though they are like, they get trained in a very accurate way. Like, I mean, not in an accurate way, but neural network architectures are really strong, right? They are considered to be very strong, but you can still not use it because it's going to take time to predict. And that's just not a business use case for you.
Yeah, so you have to balance like the actual structure of your decision-making process, because you want it to be sophisticated and give you the right answer, but you also don't want it to take too long, right? So you have to balance those two.
Yeah. And that's, I guess that's the story of, if I had to Like if there was a civilization that came from some alien world and I had to describe them what computer science is, right? I would say it's the struggle between, I don't know, the time that you take and the kind of output that you produce. It's actually a struggle between the time that you take, the memory that you consume, and the kind of output that you produce.
Gotcha.
Yeah. It actually reminds me of Rum conjecture.
Mhm.
So, what Rum conjecture says is this is very popular in databases. What it says is there are three letters in Rum, right? So R, U, M. R is read, U is updates or the writes that you perform, and M is memory, right? And when they talk about it, they put it in a triangle. So read would be in one of the vertex, update, and then memory. And the whole idea is that you cannot achieve all three of these. If you are closer to at least two of them, then you're going away from the other one. And so it is always a struggle, and people are trying to balance things. If your reads are faster, your updates would be slow. If your updates are faster, then your reads would be slow.
Mm-hmm. It's funny how there's so many different industries that when you boil it down, it really does become a tug of war between how much resources do I have, how much time do I have,
Yeah.
how much energy can I put into this,
Yeah.
and trying to balance those three things.
Exactly. And if you look at the essence of optimization, what is it? Right? Why is optimization called a problem? Because when you are looking at an optimization problem, there has to be at least two variables that are opposing each other. That's when it is an optimization problem. Otherwise, I could have given you a very simple problem and said, given a variable X, maximize it. It doesn't make sense. It is still an optimization problem, but a very uninteresting one, because you could just say X is equal to, X tends to infinity, and there you go, I have solved the problem.
Yeah.
But if you add more constraints to the equation, that is when there is an optimal solution or a close to optimal solution. We call it quasi-optimal solutions.
Mm-hmm.
And you just want to achieve those solutions because...
Yeah, exactly. It's like you have a business and you're making money, and it's like, okay, just make more money.
Exactly.
It's like there's no other constraints, so I'll just make more and more money.
More money.
But now you add resources and time and logistics and employees and holidays, and now you have all these little things to optimize.
Yeah. It's a very hard optimization problem for all the businesses.
So AI is really good at that optimization and finding the sweet spot?
It depends on what it was trained to do, but in general, yes. They are going to give you some, whatever it was trained for, right? So, like I was telling you about, we want to predict that dollar value. That's gonna likely win the bid if we are really confident that that user would be interested in that particular ad. So, yeah, I mean, it's gonna find that optimization can have like many different meanings, but yes, machine learning algorithms are. In fact, the training process is optimization in the sense, right? What are you optimizing when you are training a machine learning algorithm? Can you think of what is it that we are optimizing? We are optimizing, so there's always a cost function associated with the machine learning algorithm, right? So what are you optimizing? You're optimizing the cost. You're bringing that cost down. That's when, and once you see that the cost is really low, or that value has achieved has gone below a certain threshold, that's when you say it's performing very well. So it is the training of the machine learning itself is an optimization problem.
Mm-hmm. So for the audience, I want to ask, with all these advancements in advertising and showing you the optimal ad, does that mean when you're scrolling on your phone or when you're doing something or when you're at an auction, the ads that you receive are going to get better and better and better at predicting what you want?
I mean, the whole objective is to create a relevant experience for the users, right? And so I think you would have also noticed this, right? Let's just go maybe 10 years back. I don't know. And now you would actually see that there's lots of relevant ads or something that would relate to your interests that you would see in your feed as opposed to 10 years back. So definitely there's lots of things have changed since then. The way people understand data, study it, and then just use it to reach the audience. Now, many people would have some, I don't know, privacy concerns related to that. But the thing is, everything that happens is, it is, it does follow all the data governance rules and the privacy rules.
Mm-hmm.
And so, yeah, I mean, they have to respect that. And even so, they are able to give users a relevant experience. So I would say, yeah, I mean, I guess in near future, you would probably see, more relevant ads, and not the kind of ads that's gonna creep you out and say, how does it know I was at Starbucks, at this location or stuff like that. But that's the experience that you're probably gonna enjoy and say, hey, this was the product I was looking for, and you just go ahead and purchase it. Things like that.
I do notice sometimes that I'll be having a conversation with a friend about, I don't know, like I'm telling him I need better sleep, and then all of a sudden all my ads are about sleep. Or maybe I haven't even told anyone, but I'm kind of like thinking about doing this thing, or I'm like, I need to walk my dog more, and then I get a dog leash ad. And it's so crazy that sometimes it can like predict things that I've never told anybody or maybe searched one time. What kind of data are you guys taking into account when you produce advertisements like that?
Okay, so let's talk about the first part of the things that you were talking about, right? Which was you not even explicitly maybe do a Google search on something, and you would start to see things about maybe sleep or something. So I'm happy that you mentioned that, because I have a small story to tell you about that. There's this thing called serendipitousness, right? And machine learning algorithms are really good at that. Now, what does it mean? What it means is that a machine learning algorithm is going to produce an output that you did not expect, but it makes sense based on the data. For example, I think there was a study that said, so they did some associative analysis. I might be messing up the word here, but they found out that people who purchased beer also purchased diapers. There was a correlation between these. Like, they would usually in their cart, these two products would be together. Exactly right. So now to a normal human, it just seems ridiculous. They don't have any correlation as such, but it just made sense based on the data they had. And I was also surprised to look at some of the other data here, which is again on the line of serendipitousness, right? So it's not really about, we are breaching your privacy or stuff like that, but you just have to accept that machine learning algorithms are so smart, and that they are able to predict those kind of outputs.
Yeah.
When I was in my senior year back in college, we used to have those tech fests in college where like all the other years would participate in it, and we would be responsible for setting up questions. I can tell you that I had set up one machine learning algorithm question, okay, and the students were able to they had to find out some correlations and do some predictions, and whoever did it the best would win, that team would win. I wrote that code, okay. I knew what the correlations between the variables were, right? They were between certain random constraints in Python. But the kind of correlations that the students came up with were not the ones that I had set in the code.
But they were real correlations.
But they were real correlations.
Wow.
So it's not magic, but it's the part of that I was talking about, which is serendipitousness, right? You would not expect that to be true, but the data is just not going to lie. The data is suggesting that that's going to happen.
So when you get an ad that makes you feel pretty creeped out, it's more so a function of you being somewhat predictable as a human being and AI being really, really smart, and not so much a function of, your mic is being tapped into and people are looking through your cameras and seeing what you're doing.
Yeah, of course. There's many conspiracy theories. I don't believe in all of that. You yourself would not know that you would be interested in a product just because your subconscious mind, maybe you were driving through a highway and there was an ad. You did not pay attention to it really, but your subconscious mind kind of read it, and then you just want to buy that product, right? So you would not know why you got interested in that product, but you are. So yeah, I mean, there was this study, uh, I think some psychological study or something that was conducted where, you know, people were shown some things initially. They were not aware of it, but those objects were there in their surroundings, and then they had a bias towards those objects, even though nobody asked them to explicitly look at those objects. So it's just, you don't know what your mind is registering and the kind of things that you would get interested into.
Yeah. Yeah.
Yeah.
Being aware of bias, in my experience in geology, a whole separate field, is also very, very important.
Yeah.
I would imagine there's bias in also kind of the misconception of feeling creeped out from an ad, because you might have an ad that doesn't stick. Okay, this, I scroll past that really quickly because it's not relevant to me. But then as soon as there's an ad that's like relevant to you, now you feel all creeped out. And now you're thinking, they're watching me, they're doing all this.
Yeah.
But maybe that was one ad in 10 that was relevant.
Yeah, exactly. Yeah.
So where do you think the technology of AI goes from here? What are some of the improvements that you can see being made?
Right. I think so. Let's look at some of the interesting problems that AI is facing right now. Right. So I was having a discussion with one of my friends. He's working for a pharmaceutical company, and they're developing some solutions to medicine. And the problems that AI is facing right now is, it's not just it's not really a problem, but what happens is, if someone comes up with a nice neural network architecture, or if they are able to suggest a way to consume data in a specific way, and pass it on to some sort of machine learning architecture, and it is able to predict values accurately, that's a work that's publishable. So what I mean to say is that even in the current state of the AI, people have to, in a way, spoon feed the algorithms, because they have to say, you know what, you process this data in this specific way, perform some matrix transformation, stuff like that, and then maybe reduce the dimension of the vector to this size, and then feed it to the neural network architecture, right? All of those things, like, it's just, you have to be very specific. You have to specify, okay, this is how the machine learning algorithm learning should work. And that's when you're able to get the best out of it. Even if you change the small parameters like learning rate or something, or I don't know, regularization, it's just going to perform ridiculously bad.
Mm-hmm.
So the takeaway from this is, people are still trying to kind of spoon feed. So it's still in its infancy, right? AI is still in its infancy, and there's a long way to go for AI, because you just have to specify architecture so many times. There's a popular CNN architecture that's able to, process images really well. There's popular neural network architectures that are able to generate images really well.
Mm-hmm.
So, yeah, I mean, I think there would be many advancements on this side in order to maybe have a lesser effort on this side in order to decide architectures. Maybe hopefully we would have something in future that's gonna say, hey, I found this architecture that's gonna work really well, rather than humans kind of implementing those architectures and saying this is the best working architecture.
Yeah.
The other problem with AI is, honestly, I don't think that this is a problem, but definitely as a scope of improvement. The other problem with AI is, I don't know if you heard about this story, but there's this self-driving car business in San Francisco, and there was one incident where that self-driving car it hit the pedestrian, one of the pedestrians. I don't know if the pedestrian was on the road or whose fault it was, but the crazy thing that happened after that was that self-driving car, it just detected a collision. Okay, it did not acknowledge that it was actually a pedestrian that it collided with, and so the only thing that it detected was a collision. So now what it was programmed to do for that was to park the car. Okay, after that, makes sense. I mean, if there's a collision, maybe find a safe way to park the car and get out of harm's way, for example. What it ended up doing was there was a pedestrian involved in the incident, and it kind of dragged that pedestrian with it when it was parking, because it was just programmed to do that.
Yeah.
So maybe the way it sensed the environment was something that it did not see in the training process, right? And it's a problem that would exist forever, because you cannot possibly create all of those situations that the machine learning algorithm should be prepared for, right? So that's another problem with AI, is there would always be one test case or the situation that it has not seen, and at that time it would have to make a best guess as to what it has to do, right? So that's another problem with AI. There's just one more, and I'll just briefly describe it. Is we talked about image recognition, right? So you'd be surprised to know that let's just say that there's a self-driving car. It encounters a stop signal, right? So the way it understands it is it has that processing logic. It sees stop signal and it would stop, or maybe always stop, or whatever. It would take an action according to what it saw, the signal, right? But then there are adversarial approaches. You would literally just change, I don't know, 4 or 5 pixels to the image of stop. A human cannot see those changes, right? And the machine learning algorithm would predict completely different. So instead of seeing it as a stop sign, maybe it would see as, I don't know, 70 miles per hour, right? So there are many adversarial attacks that people can conduct on a machine learning algorithms, just because of the fact that it was not trained in a way that, just the changes of 4 or 5 pixels, you could not even imagine. Or maybe someone could just go to that stop sign and just do that, and all the self-driving cars would go out of business, right? So this adversarial thing is also very important.
Yeah.
And it has to be addressed. So I think in near future, these are some of the important things that AI has to address. And I definitely see AI getting used a lot in healthcare. At the moment, still people are using generalized medicines, but maybe people would, in future, with the help of AI and with the help of all the technologies, we would be able to understand every person in the individual sense, and then they would be able to come up with the medicine specifically for them. If you want to get creeped out with that, for sure, but it's just going to help you much better than a generic medicine. So yeah, I mean, definitely excited and looking forward to how that changes. And then data privacy is something also that's very important. Data governance. There's so much that we can talk about in AI, honestly. This is a question that we can keep talking about forever. But yeah.
For sure, we can keep going. Let me give you an analogy just to make sure that I'm understanding this correctly and that the audience understands. So AI as it is right now is kind of like it's like building a house or something like that. But we have to tell it the blueprint in which, like, okay, you need to have a room here, you need to have a pillar here. And it can't really come up with that itself. Right. So we have to it's very much on the training wheels, and we have to tell it which direction to go.
Yeah.
And then also, it's almost a double-edged sword because it is so sensitive to small changes in data. When there's a small change in a very complex environment like the streets of Austin, Texas, it might predict something completely different.
Yeah.
So if there was a crazy dude that wanted to spray paint the stop sign, then it would just go right through the stop sign.
Yeah. I mean, not even spray paint. It's about, so spray paint is obvious, right? So if a law enforcement officer comes across a spray painted stop sign, they would take measures to correct it, right? But the worst thing is, the bigger problem is, nobody's actually able to find the root cause of the problem, because you literally made 5 pixels change for a stop sign. And when I say pixels, it may be just small marks in the stop sign, right? And you just know exactly why this is going to work, because you can actually define a machine learning problem, and it's going to give you a stop sign that for a user, for a normal human, it looks like a stop sign. But the machine learning, a state of the art machine learning is going to predict that to be, I don't know, 70 miles per hour speed limit sign. So that's a bigger problem. It's not about, you spray painting. That's very obvious. Someone would just correct it the next day.
So even if it's like, I don't know, someone drives by and they hit a puddle, so there's like some specks of mud that fall on the stop sign.
Yeah.
Even though the sign's completely red and it says stop, even though like it's so obvious that it's a stop sign to any person looking at it,
Yeah.
AI would treat it as something completely different because of those little specks.
Exactly, because of those little specs and the fact that it did not come across that kind of data set in its training. So it had to make a best guess, and the best guess was something completely different, right? So that's a big problem.
So how are those cars even able? Because I see them around the university. I mean, they'll drive around the apartment buildings and things like that. How are they even able to drive around? I would imagine there's a lot of pixel changes when they're.
Exactly. So here's the thing. All the smart folks who are building those algorithms, they are aware of those adversarial approaches, right? So what they do is when they are training their machine learning, all of those algorithms like image recognition algorithms, they are keeping that in mind, and so it's like a constant battle, right? So let's say you found out that okay, these are the things that these people are doing. Let me add a patch to the machine learning algorithm so that it's still gonna predict it to be a stop sign. So now the adversarial people who are on the adversarial side, they would know that okay, they have added this patch. Now they would do something else, and this cycle keeps going on, right? So it's like now we have reached to an almost equilibrium, right? And the way you push the equilibrium is to on either side is you come up with a smarter way to outsmart the other person. It's the same with the cryptography, right? The way you break the passwords. There would still be people who would in this world who would be able to I don't know, bypass your very secure accounts, but they would just not do it because uh, they just don't want to. They would do it to a person or a larger organization where they would have a larger benefit, right? You would have heard about a lot of people, breaking into someone's system and the data breach and all of those. You still keep hearing those news, right? So it's all about. So they are also adversaries. So the similar thing applies to machine learning and AI. Is, of course, they are aware of those adversaries, and so they have patched their machine learning algorithms with the capability to not be affected by that.
Mm-hmm.
But if there's a smarter adversary, you need to keep upgrading.
So it almost sounds like you're talking about like hackers and people that want self-driving cars to barrel through stop signs. But what about just like accidental, like I was saying earlier, like some flicks of mud get on the stop sign, or maybe someone. There's a lot of people that like to put stickers up on things, things like that.
That's definitely going to. I mean, there's no way if there's a sticker on stop sign and it almost covers it, then of course there's no way for it to predict it's a stop sign, right? That's an obvious thing, and there's no solution to it other than just removing those stickers from the stop sign. But the harder problem is definitely when it is very stealthy, right? It's just it's not very obvious to human eyes, but it's still there. And the specks of mud, I believe they would have trained their algorithms to not be bothered by that, because specks of mud is much different from a careful orchestration of 5 or 6 pixels.
Yeah.
Specks of mud is like very obvious to machine learning, because we are definitely that advanced that specks of mud are not going to change the decision. It's still a stop sign.
So it seems like the more we implement AI into things, the more vulnerable we can be, because you could have someone come along that's like, say that all cars are self-driving. You could have someone that goes along and just like, I want everyone to just constantly have a green light always. Yeah. Like there's a scene of that in like The Simpsons or something. But and so you could essentially, if you wanted to commit like an act of terrorism, change a couple pixels in the widespread system, and now everyone's cars are going crazy.
Yeah.
Wow.
So I mean, you can think of it this way, right? What would be the what exactly would be the motivation of a person to do that? I mean, there would be like some sadists who would just want accidents on the street.
Yeah.
But then there's another thing is maybe there's a competitor for that self-driving business that's just booming, and they would want to introduce those kind of issues on the street, right? So that's the reason why businesses are not just facing challenges with the growing amount of data and the way they have to be so accurate and fast, but there's these adversaries that they have to be, especially with very sensitive things like self-driving cars, right? They have to be very sensitive about those things.
So there's a big cybersecurity problem when it comes to designing the systems.
So cybersecurity is something when someone, that's of course, that's one of the obvious problems. Every organization would have, cybersecurity folks just making sure that nobody gets into their systems. But this is not about getting into their systems, right? And that's the, for the lack of word, beauty of it is you did not have to change their machine learning algorithm, right? The self-driving car, you did not do anything to it, but you were still able to make changes to the environment that it's perceiving and making decisions based on that. That's much easier. You don't have to break into the organization's code and modify it. You just modify the surroundings.
Wow.
Yeah.
That's crazy.
Yep.
So, do you have any ideas of what that could mean for things other than self-driving cars? Like maybe for what you guys do?
Interesting. Yeah, I mean, we do have like many fraud detection processes, and we want to identify some of this. So this is just an example for something that's specific to us. Is we want to identify that the ads that we are placing for the businesses who are our clients, we are placing those ads on some legit websites, and not those websites where there's no traffic at all, because that's not going to be useful to the business. Even though they would be successful in placing their ads on a website, it's actually a site generated by a bot. Because let's just say you want to earn a lot of money, right? You would create a random website, and there would be a bot who would just participate in those auctions, right? They would say, okay, we have these many places to place ads in our website, and everyone would start bidding, and you would get a lot of money for them being able to place ads on your website. So we are taking measures in order to identify that the places where we are placing ads, it's just not a bot or something, or just not, it's just legit. So we have to identify that. It's very important.
Yep. So what's some advice that you would give to someone looking to get involved with AI? Maybe there's a student at UT who's in the computer science school who's very passionate about AI and wants to get in the field or something like that.
Yeah. So I think this is my personal opinion, but I think it's very important to to not just learn about the libraries. Like a lot of people, when they start out with machine learning and AI, they are swayed by very simple libraries that you have in Python, right? Or other programming languages where you would just use those libraries and they are able to predict things. Those are some pre-trained models, and you just have to tweak some parameters, and it's just like toys. You're playing around with it. But I guess if you really want to get involved in AI and really advance, it's so important to get the fundamentals right. So what is the mathematics behind it? What is the intuition behind neural networks, for example? Or what is the intuition behind a decision tree? When would you want to use a decision tree and not a neural network? Like, ask yourself all of those complicated questions, right? And try to get the answers to those questions. So definitely understanding the start with understanding the fundamentals, and then move on to the applications. So that's definitely one of the important things. You would still be able to find a job where you just have to do that, but there would not be huge progress unless you understand the fundamentals.
So instead of going onto the internet and finding already made machine learning libraries or things like that, and just playing around with things that are might be a little too advanced for you at the moment, just go back to the fundamentals, put your nose in the dirt, and try to understand those big questions and very fundamental concepts, and then kind of work your way up.
Yeah, I think that's what I call is understanding what's happening under the hood, right? You are able to drive a car, but if you're not aware of what's happening under the hood and you just, you're stuck somewhere, then you'd be like, I just know how to turn the steering wheel and hit the brakes and stuff, but I don't know what exactly is happening under the hood. That's where that's where your career would stop. You'd just be able to write those algorithms, but not really improve them or come up with something very interesting.
I love that saying.
Yeah.
Understand what's under the hood.
Yeah.
I'm going to steal that.
Yeah.
Is that okay?
Of course. I mean, I'm stealing it from one of my professors at Purdue, so feel free to.
Sounds good.
Yeah.
Thank you, Purdue professor, for the wonderful saying. I'm sure he stole it from somebody else.
Oh, yeah, I mean, I actually mentioned his name when I was writing my statement of purpose. He's a great professor in database, and I'd always look up to him. He's just a very smart guy, of course. But yeah.
Are you familiar with the phrase "learn to code"? Just like if someone's on the internet and I don't know, they're complaining about their job at Starbucks or something, and someone will go, "Just learn to code."
Yeah, I have heard about it.
Is that actually legit? Like, can someone who is working like maybe a blue collar job and wants to get a better paying job, or they want to work from home or something like that, is it legitimately possible to go on the internet and take free or cheap courses and then work your skills up to being a programmer?
I think this question can be very so it depends on how you interpret learn to code. Okay. Because if you learn to code, it's just not enough. Let's say you learn to code and you just want to know how to write code in C++, for example, right? I feel like that's not going to be enough, and just being able to write code is definitely not sufficient. You have to understand what exactly is happening. Many people, they tend to they like, I think the AI example, right, you can apply it here as well, is they are able to write the piece of code, but they don't really understand what's happening when you maybe execute a statement. For example, a very simple example, right, so people can relate is there's a statement called sort, right, and you're sorting an array. Now, if you learned to code, right, and you were working for an industry, and you have written this piece of code, and now they ask you to say, hey, we are facing some problems with the latencies, for example. It's just a bit slow. Can you see what's happening with that code? Now, sorting algorithm is not a very simple algorithm. It's a very fundamental and simple algorithm, but there's lots of things happening behind it. It's an algorithm that has an n log n complexity, which means if you have maybe 1 million elements to sort, it's going to take the order of n log n time to sort those elements.
Okay.
But if you just learn to code and you did not understand all of those things, all of those algorithms, all of those data structures, right, that's really important, then you would really not be able to take the feedback and modify that code. So it's really important. Definitely, they would be able to learn all of those things from. I think, to answer your question, yes, they would be able to learn a lot of things, but it's just really important that they understand what writing code is.
Gotcha.
Because on the face of it, it may just seem that learn to write code. Okay, so I'll just learn to write code, but it's just much more than that. It's about you understanding what's happening under the hood.
Exactly. It does sound a lot like your advice for learning about AI and machine learning. Just understand the fundamentals, understand the systems that are going on, understand what's under the hood, and then, actually writing the code. I mean, I feel like it doesn't. Correct me if I'm wrong. I feel like learning how to write the code itself and learning the syntax is less important, especially now with things like ChatGPT, where you can kind of just tell it, hey, I want code that does this, this, and this, and then it'll just write it for you.
Yes.
Or like, what's the syntax behind this? It'll tell you.
Yeah, exactly. And I was actually about to mention that is the things are kind of reversed now. Is it doesn't matter what kind of language you are really proficient in most of the cases, and that's why you would see a lot of interviews that these large corporations conduct. They give you the option to choose the language because that's hardly what they would care for. They don't care what language you can write. What they want to understand is, are they able to solve problems? Are they able to break down a business problem into an engineering problem,
Yep.
or computer science problem, a programming problem, and then just solve it? So
that seems to be a reoccurring theme. On the first episode, I talked to, do you know Dr. Michael Perch? He's also a data scientist.
I've not heard of him.
So he's a data scientist at UT, and
Okay.
he does geostatistics.
I see.
Pretty similar stuff to what you do, just in geology and for oil companies and things like that. And his big advice with AI was like, it's going to give you competency, but it doesn't have a lot of comprehension. So the comprehensive aspect, right? Like the creatively solving problems needs to come from you, which seems like exactly what you're saying. When you need to understand the fundamentals and what's happening behind the curtains so that you can creatively solve the problem and use your own brain instead of just relying on things that AI can probably do for you.
Yeah. And if you look at the differentiating factor among organizations or within an organizations based on who is earning more and who is earning less, right? So do you think that a tech team manager is writing a lot of code? In most of the cases, they are. Maybe somewhat they're writing a code. But most of the times, they are making decisions and saying, hey, you know what? Let's do this and write code this way so that we are able to solve a problem. So you can see how learn to write code is still going to land you to that position. But in order to be a manager or someone like an architect or a principal engineer, you just have to know the fundamentals.
Yeah, you have to know how to conceptually, like, I'd imagine that they're coming up to you with, or like if you have a customer that you're writing code for, they're coming up to you with a pretty complex problem. And so if you want to be, a kind of a big shot in what you're doing, or you want to be more than just a low-level programmer, you're right, you have to understand, like, fundamentally, how can I take what I know about computer science and then make the problem that you're having or solve the problem that, my customer is facing.
Yeah, and you'd be surprised. Actually, this is not surprising at all. People just come up with, so as an engineer, you cannot really predict what kind of requirements you'd be getting from a client because you have this engineering mind and you just want to solve, engineering problem. Okay, I'm so interested in it and you get so involved in it. But then you realize that you missed something very simple. I'll give you one instance of this. We were developing this analytics product for merchants, and there was this metric. So what we used was to print anything on the UI, we would use floating point numbers. So it would have, maybe 12.00 or 12.54 or something like that. That was the format. And there was this metric that was indicating count, and it was showing count as 10.00 or 5.00. So for us, we did a lot of testing, on that product before we showed it to the product team. And then the first thing that they noticed, it took us 2 weeks to come up with that and just do a lot of stuff. It was well tested. It did not break. The first thing that they noticed was, and this was just, I think 30 seconds into the call, they said, why are we seeing count as 12.00? Should it not be 12? So the thing is, there can be so many different requirements that you would see coming from the clients that you cannot, as an engineer, predict. There can be some very complicated requirements too. Like, for example, in our domain, right? I was talking about the way you want to spend the budget. Let's just say that the way you have written your software, it spends the budget uniformly, right? Now, if there's a client that comes up to you and says, you know what, I want to spend 10% of my budget today, 20% tomorrow, 30%, and then so on, right? 50% the next day. Then you have to think about, okay, this is something different. How do I do that? You know, there's an easier solution to this problem, but just clients are just gonna keep coming up with something that you could not have predicted, and you have to adapt to it.
Yeah.
So the only way you'd be able to is when you have better understanding of it, and not just the elementary way of the things that work.
Gotcha. I want to ask you a similar question to what we've been talking about and kind of the advice that you give to someone looking to get an AI, but now just advice to someone who's just entering that computer science field, maybe someone who's doing their undergrad or someone who's doing their undergrad. What would you give to them? What advice would you give to them?
Mm-hmm. I think my advice would be, and this is from my learnings, is I did not start participating in a lot of tech competitions or hackathons early on, because like I used to get worried about how people would judge me. I don't know, but I would definitely say that they should start participating and start getting practical experience early on. I think this is, I'm talking about the tech field in general. Like if someone is doing computer science major or computer engineering, is they should start getting practical experience early on. That's very important. So you are prepared for the industry if you want to get into industry, and if you do want to get into academics, then I guess I don't know if I have a great advice for those, but definitely if you want to get into tech industry, start getting practical experience, start participating in those tech competitions, because I had this incident. So when I finally started to participate in those tech competitions, so my college used to have those, and the students from the senior year would actually conduct it, like I mentioned, right? So I was giving an interview, and one of my seniors, so she was asking me questions about pointers in C++, and after I was done with my interview, she said, your knowledge is, and I was in sophomore year at that time, and she said my knowledge about C++ pointers was at par with the students in the junior year. So I just realized that a lot of people have this feeling that they are not good enough, and so they want some time to prepare themselves and then get out and do all of those things, but there's no good time for it. It's just get started as soon as you get an opportunity. Don't worry about someone looking at you like, oh, he did not make it in the competition. Just do all of those things early on.
You'll learn through the experience itself.
Yeah,
is what you're saying. So hackathons, tech competitions. What about internships and things like that?
Oh yeah. So I actually did my internship only in my junior year, but I also saw like a lot of students going for some research and internships in their sophomore year. But yeah, definitely internship is going to give you a great experience, especially with some colleges. They have this they do this semester long internship as opposed to just doing internships during summer. That's definitely going to give you a great experience in the industry if you eventually want to transition to that. So yeah.
And what's your experience with grad school and getting into a master's program? What advice would you give to someone later in their undergrad who's looking to do a master's?
Yeah, I think that's my story. So I'll give you my thought process here is, before doing my master's, I had 3 years of full-time experience. And whenever I was working on a problem, I always wanted to understand like what exactly is happening here. I'm just writing this piece of code, and I want to understand why people are using these kind of methods, right? For example, and I had this, so one of my teammates, when I was working with Visa, he did his master's, and there was something unique that I noticed about him. Okay. Whenever we would solve a problem in the team, like something related to the project, I would just take his advice, and he would share some papers with me, like the published papers. And those papers were very relevant, and I was just very I look up to him even now is because he had this he had this kind of knowledge that even the people who were senior to him in the industry but they did not do graduate studies did not have. It's a different path for every person based on preference, but I really loved reading those papers and understanding things in depth, right? And so that is when I think I decided that I should I should be in an environment where I could do more of that, is to study papers, get in depth of things, because that's something that I really like. In fact, there's an itch. I always have this itch when I'm writing something and I don't understand it completely. Even when some task is given to me, I just have to understand, like, what is the origin of this task? Why do we really want to do it? Asking that very simple question of why. So that's the reason why I just wanted to pursue a master's, and it definitely met my expectations. So the original question was, what was the experience like, right? So
what was any advice that you would give to someone trying to go into masters? But what the experience was like is also
okay.
Go ahead. Yeah.
Yeah. So I think the advice would be, you should pursue graduate studies or higher studies after finishing a bachelor's if you have those kind of feelings that I had.
Kind of
Right?
like why are we doing the things that
Yeah.
we're doing? Really get deep.
Yeah.
Under the hood.
Yeah, under the hood. Yeah. Because otherwise you would just find yourself in a very in a position where you're just not enjoying it and you're just doing for the sake of it. I would definitely not suggest doing that, especially if you think of doing PhD and thinking, I would have this PhD degree and it would just look good on my resume. That's definitely not the right motivation to be in graduate studies. And so you have to. So the advice would be, you have to have this mindset of getting into the depth of things, and you have to prepare yourself to what graduate school is gonna make you go through, because Purdue has a very rigorous academic curriculum, and many graduate schools do. It's because that is the reason why it's called graduate studies. Is uh, you know you're done with the basics, but now you have to do something specific. So if you're not really interested in that, there's no point in pursuing it.
Mm-hmm.
Yeah.
You need to have the right motivation so you can get through the academic challenges that you're gonna face in grad school.
Yeah.
So would you say grad school is more difficult than undergrad as far as coursework and things like that?
I mean, it definitely gave me. It was more specific for me than how it went for me during undergrad, and for obvious reasons. Like, you have some very specific topics that you indulge in rather than talking about things on a high level. So I would not say it was hard, but it was definitely very involving, and it kept me busy all the times throughout the semester, especially because I did my bachelor's back in India, and in India, usually the pattern is that a lot of focus is on the exams. But when I was here and I was studying, they just pay attention to everything, like the assignments or the projects that you're doing, and they just keep you busy throughout the semester. And especially because it was the graduate studies, you were getting into depth about everything. And I found myself thinking about different topics, not just when I was in front of computer, but when I was walking and just, thinking about those things. So that's really good. If you're really involved in a topic, you would enjoy it. Yeah.
So in your opinion, what would be the most useful skills for someone who is going into a computer science job, going into grad school, just going into the industry in general? It seems like, from what you said, practical experience, and then, just asking why. Like, why are we doing this thing? We're doing it because of this. Okay, why are we doing that? Okay, we're doing this because of that. Okay, why are we doing that?
Yeah. Yeah. I mean, I think so. The question is, what is going to make you successful in tech industry?
What are just skills that are good to have, good to develop, especially when you're kind of making your way up into tech? Or what skills have been very useful for you?
Yeah, I think there's so many things that are desirable, like So first of all, you should not just be able to solve the problem, because I feel like 4 out of 5 people would be able to solve this problem, a particular problem that's given to you. But what's more important is you are able to express it. Like, you are able to say, okay, you know what, this was my approach, and you are able to successfully reason about it and then write that code. Because especially when you're in an industry, you're not going to work in silos. It's not like you developed a product and nobody asked you about it, right? You have to communicate. And so those interpersonal skills are really important when you're working together, which is always, you would be working with someone, right? And I think when you're looking at a problem, you have to be careful about um, all the special cases. Like, I think we touched upon it a bit when we were talking about AI and how you can break a machine learning algorithm, right? Just by doing some manipulations in pixels. So you have to have this ability to find out those corner. We call it corner cases, right? Popular term. If you are able to write a code, then also figure out those corner cases. Let's just take a very simple example, right? You want to divide two numbers, right? It's a very simple. Write a function to divide two numbers, a and b. So a divided by b, and you just return that value. But what did you miss when you were writing that? You just assumed that the denominator would never be 0, right? So if you just did not add a check there, then if b equal to 0, say something, through an exception or whatever, you would end up breaking a production code. Right? That's bad. So this is the characteristic that's valued a lot in industry, is you being able to identify all of those corner cases. This was a very simple example, but let me tell you, corner cases manifest themselves in such a complicated way that sometimes they are really hard to identify. So you have to have that knack for looking at all of those specific situations and just write a robust code, maybe.
Good intuition.
Yeah, intuition plus a good study of the problem. Um, Intuition would give you the high level idea about this is how I should approach. But then if you go into the depth and really understand the problem and say, okay, what if the input is this? Would my code break? So, those are the things that are really valued in industry.
So understanding what exactly your customer is asking from you, and then what could go wrong.
What could go wrong? Yeah. What could go wrong is really important, because let's just say there's a single machine. We were talking about horizontal scaling, right? So let's just say there's a single machine that's handling requests from 10 clients, right? Now, if there is one request that comes from one of the clients that you did not prepare your code for, then that machine goes down, and all the other 9 clients are also not going to get their request served. I mean, this is a very rudimentary example. Of course, there's intelligence on top of it that's going to route it to some other servers. But I'm just saying that it's going to have a larger impact than you can imagine when a code breaks.
Mm-hmm.
So it's important to look at that. Yeah.
Is that one of the downsides of horizontal scaling? Is that when something goes wrong, it goes wrong for the entire system? Or
that's actually the upside of horizontal scaling.
Oh, really?
Because let's just say that there's 10 machines that you have, right? And if one stops functioning, then why would the other 9 machines stop functioning? There's nothing that went wrong with them. On the other hand, if you had just a single machine, a vertically scaled machine that was taking care of all the requests, and something bad happened to it, then you're gone. You're done, right?
Mm-hmm.
That's a single. So we call it single point of failure.
Gotcha.
So you just don't want to have that problem with you when you're in business.
And is it easy to find the exact machine that failed?
Yeah, I mean, there are many tools that are going to help you figure that out. So, I mean, we are in a position where it's like really fast. In fact, there's so many backup mechanisms that you have set up. That's we call it infrastructure, right? The way you have set it up is, as soon as you see something going wrong with a machine, the backup immediately comes up, and it assumes the position or responsibilities of the other machine. So yeah, I mean, we call it replication in databases, but like a similar kind of concept is adopted in all of the systems. You just replicate the data or have a backup server that's gonna take up the responsibilities.
Gotcha. So when you horizontally scale, you have a nice support network of, okay, if this fails, then, this machine's going to take its place and
Yeah.
things like that. Okay.
Yeah.
So I'm curious, what programming languages do you use most in your day-to-day career?
I mean, statistically, there has to be one, right? And I would say it would be Python, because it's very easy to prototype in that language. If you're prototyping, I would definitely not suggest using C++ or Java for that.
Prototyping meaning?
Prototyping meaning so you come up with an idea and you just want to test it.
Mm-hmm.
So you write a quick piece of code.
Gotcha.
And just test it out. So that's really easy in Python. I've done that a lot. And of course, all the machine learning projects that I've worked on were in Python because of the great library support that it has with the ML community. So I would say Python is that language, but that doesn't mean I have inclination to that language. It just depends on the context. It just depends on the context. If I want to write an application, I have a good framework support, I would use Java, and it just depends. It just depends on the situation.
Gotcha. So it's Java, C++, Python, just the normal, big coding languages.
Oh, so if you're asking what kind of coding languages I've used, I have also written code in Golang, Scala. Yeah, I mean, these are the popular languages I can think of. I mean, a little bit of some of the querying languages, like Q is one of the querying languages, SQL is one of the querying languages, Hive is querying language for big data.
Yeah, I guess I wanted to frame the question. I should have asked it a little better. I'm sorry.
Mm-hmm.
I wanted to frame it in such a way that, someone who's going to go into the tech industry as a programmer, developer, knows kind of, okay, what am I getting into? What languages are they using?
Mm-hmm.
Are the languages that I'm learning in school right now going to actually be applicable when I get a job? And it seems like the answer is yes.
Yes. The answer is yes. And sometimes it's also because of the legacy code. Like if you join an organization and all the legacy code is written in, for example, Java, then of course you'll have to work with that. But the good thing about languages is that you would get used to writing code in that language even if you don't have any experience with it. Like I mentioned, right? All the organizations, when they're taking interviews, they don't really worry about, especially at the lower levels when you're just starting out, right? They don't care what kind of languages you are aware of. So you should also not be specifically worried about what language is in demand. Of course, you could look it up and I guess you'd get, I don't know, Python, Java, all of these languages at the top, maybe Golang, right? But I think that's not something that anyone should be worrying about is, what's the syntax of the language and what kind of language would I be getting into? Mm-hmm. That's not one of the important concerns.
So back to what we talked about, you should be more worried about understanding the fundamentals.
Yeah.
And, solving practical problems.
Yeah.
And not so much how many languages do I know?
Yeah, if I were to look at a resume, I would definitely skip the section where they mention, the languages that they know, especially when I'm looking at a candidate who is just starting out.
Yeah. And I want to circle back to our discussion about your kind of initial motivations for going into data science and why you chose it as a career. You already outlined that for me, but I am curious, has that changed with time? Has your motivations as you've gone through school and now are in the industry, are they different than when you first started?
This would be a process for everyone who is in computer science or data science. Is they would start out with something and then they would maybe change their direction, career direction a bit. So it has happened to me as well, and it would keep happening in future. It just depends on the trend, right? You cannot help it because everything is changing so dynamically. and you have to kind of adapt to it. But in terms of interest, I would say my motivation has changed, but the better way to put it would be uh, they have become more and more specific. I started out with as being a software engineer, just writing code, and that's what I had in mind. Although I knew that I would be doing backend development, but what exactly in backend development, I did not know. But then it would just keep getting more and more specific, and that is what is expected of you. Is because when you're at a higher position, overlooking something, you have to be expert at that. Anyone who is an architect, you don't expect him to be able to write a code for a web server in JavaScript and also be able to write queries, right? And for databases. So they have to be specialized. So my motivations have changed, but I think they have, in a sense, they have become more and more specialized.
So do you see the people who the longer that you spend, maybe some of your seniors where you work, their motivations are, very highly specific and very niche. And then do you see the people who just enter, they're kind of almost like a deer in headlights, and they're like have motivations scattered everywhere. They're very broad.
Yeah, it's not just with the industry, it's also with how you advance in academics, right? So let's just say that there's a person who is doing bachelor's in computer science, and then a person who is doing master's in computer science, and then a person who is doing PhD in computer science.
Yeah.
Do you see the level of specialization?
Yeah.
Like if you go to PhD, you would ask, what is the topic that you are researching? They're not going to say, you know what, I'm researching algorithms. That's not an answer. They would probably say, I'm researching this aspect of this algorithm and how we can improve it.
Mm-hmm.
It's that special. It's that specific. So definitely, I think the same thing applies to the industry. I've seen so many people like the architects who are experts at graph databases or like some very specific things, and they are really good at it.
Mm-hmm.
Yeah.
A bit of a tangent here, but I did see on your, I think on your LinkedIn, you had a really, really good score on the CSBE exam.
Oh, the CBSE exam?
How do you say it?
CBSE.
CBSE. Okay.
Yeah.
Dyslexia got the better of me on the paper. So that's a very big deal in India, right? That exam.
Yeah, I mean, I think study in general is like very seriously taken in India, and the standardized exams like CBSE or the JEE exams that's going to get you into some of the renowned colleges in India, they are definitely taken very seriously. Yeah.
So how did you go about preparing for that test?
Yeah, I mean, so I'm just trying to think of an advice that's going to be different, that's going to be based on my experience and is different from the standard advices like, I don't know, sleep 6 hours every day or something like that. So yeah, there's one thing that I've noticed about a lot of hardworking people is they have this tendency to do everything. Like if you were to read a book and then appear for an exam where the questions will be coming from that book, you have this tendency to read everything, right? But my philosophy has always been to first find out what's important and then get to the depth of it, because if the exam is really prepared by a person who thinks well, then they would be giving you questions about something in depth. Now, you have limited time, right? So this is also an optimization problem if you think of it. You have a limited time to prepare for the exam. Would you want to cover the syllabus in breadth, or do you want to prioritize, find out the important topics and cover them in depth? So I go with the second one. And it's just, I would let go of maybe 20% of the syllabus, not even touch it at all, because I just know that it's not important. So, the ability to identify what's important, maybe looking at the past exam patterns and just seeing, what kind of questions they ask, that's going to help you a lot in I think, going through any standardized tests. In fact, in general for academics, this is what my approach has always been. I'm fine with losing 1 or 2 marks, but I want to get that one question really right. That's very important.
And exam culture is, I mean, the SAT is really, really important here. But it's not like especially amongst people who are pretty hardworking or want to get into a good school or things like that. But I'm wondering how that differs from India, or like most, if not like 90-something% of the adolescents in India who are getting ready to take that test are very, very serious about it.
Yes, they are. And I think they do not have any other option. Let me tell you why. So the standardized test, the JEE exam, which lets you in to many of the engineering colleges in India, 800,000 people, more than 800,000 students appear for it every year. Okay. And I can give you a slight estimate of how much you would have to score or rank in order to get to the college that I was at. So for my college, I think the cutoff was 3,000. So if I'm doing the math right, that's more than 99.9 percentile. Okay. So, and if you want to get into a really good college, you have to have a rank that's, maybe, I don't know, under 10,000 or something. So this is the bigger challenge for people, because a lot of people are appearing for it. There's no other option but to take it religiously. And you have to study hard to get into those great colleges. And a lot of people just try to, get into many of those colleges, and they have to study hard. In fact, just to prepare for that exam, they after graduating high school, they actually start studying for it 4 years before even they have to appear for that exam.
Wow.
So yeah, that's how cutthroat the competition is. And yeah, I mean, people take it very seriously.
Is that part of the reason why there's so many, I know there's so many good programmers coming out of India, and I know that there's a lot of outsourcing of programming and a lot of tech jobs with India. Is that part of the reason? Because there's so many people and there's so much competition that you're just really chipping away and finding like the cream of the crop?
Yeah. So there's one thing which is hardworking, and there's one thing which is, someone who is like really expert at things or has a great IQ. Now, most of the times, if you find someone from those top colleges in India, like IITs are considered a big thing, right? So one thing I can guarantee you is, and even in your future you would see this, is if you see a person who is from those colleges, I'm not saying the other colleges are bad or people are not, smart, but this is definitely a filter that if the person passes that filter, then they are going to be smart. They are going to be absolutely, like they have this knack for things. So that's the reason why many people who graduate from those colleges, and especially with computer science degree, they are just really able to get things done. They not only were they hardworking, because they had to be hardworking to get into that college, right? Beating 800,000, like competition among 800,000 people, right? So they definitely are hardworking, and they are like very smart people. So yeah, I guess that's the reason why. And the coding, it also depends on the coding culture, like the kind of culture that the college has. And our seniors would organize all of those classes, and many like people in a lot of juniors would go to those classes. It was just free of cost. It's like a club, but a coding club, and they would just go to those classes and learn from them.
Mm-hmm.
It's just a culture thing. So.
And from your time in India, have you seen a lot of people moving to the US or moving to the West to work? Or are there a lot of people who stay in India and just work remotely?
Stay in India and work remotely, or like stay in India and work. I mean, work remotely or otherwise, but stay in India. Is that a question?
Yeah, like work for a Western company or, a US or Canadian company, but you're working in India.
Yeah.
Yeah.
So I think, like, based on my friend group, I would say there's a 30-70 split probably. So 30% of the people would be coming to the US and gaining experience here, and 70% would stay back. Now, out of that 70%, maybe 60 to 70 would be still working with multinational corporations, and the remaining would be in some of the local industries or government jobs.
Gotcha.
Yeah.
Okay. So, last two questions here.
Mm-hmm.
If you could repeat your journey through tech and computer science, data science, is there anything that you would have done differently?
I think I touched upon this, especially during my studies. I guess just go out and try new things from early on to get practical experience. That's something that I would definitely do, which I hesitated. And what else? Yeah, I think the exposure part was really important for me, and I felt that when I felt that my peers were ahead of me because they were getting all of that exposure, but I was not. So definitely that's something that I would change, not just in the academics, but also when you're working on things in tech, when you're working for an organization, just get a lot of exposure. Try to do things outside of your work as well. Try to learn things outside of your work as well from early on.
What exactly do you mean by outside of your work?
So when you're working on a problem, you come across maybe some sort of implementation that you have to read something to understand, right? But your project should not be the one that decides what is it that you're gonna read. So you should also be reading up on the related topics, and you should be really proactive about it. Maybe spend some time every weekend, reading on things. And that's what I've done. In fact, I have two of my friends, and we get on a Zoom call every weekend, and then we would discuss some stuff about AI. So one of the guys I was mentioning, right, he's working with pharmaceutical company. So he's a very smart guy into deep learning. And then there's this other guy who's also like very smart. He also worked with Goldman Sachs, by the way, back in India. And we just discuss things. We would ask a random question. Maybe I'll give them some algorithmic questions, or he would give us some system design questions, or he would talk about some latest trends in machine learning. So that's the thing that, I learned from my past. And so that's the reason why I made that change and made sure that, I'm doing that now. So, yeah.
That's awesome. Yeah. I need to do that with geology. Just get some buddies together for a Zoom call, talk about rocks.
Definitely. I mean, my philosophy has always been the group of friends I'm with. Mm-hmm. I always want to be in the lower 50 percentile of intelligence. Now, this is very counterintuitive because if you are the smartest in the group, you feel really good, right? But there's a caveat to it, which is you're not getting to learn a lot. Mm-hmm. So
you yourself want to be
in the lower 50 percentile.
Gotcha. Okay.
And I'm happy, and I'm very happy with satisfying this constraint that I have to be in the lower 50 percentile, because I have the remaining 50% of the people are smarter than me, and I'm going to learn a lot from them. And if you keep doing that in your life, you'd find that it becomes more and more hard to satisfy this constraint, obviously, right? So, yeah, I mean, that's what I do.
Yeah. So, flipping my previous question on its head, what decisions are you really grateful that you made?
I think getting exposure to many different disciplines. Mm-hmm. I'm very happy that I was able to do that. Get my hands on web development, app development, machine learning, and databases and stuff like that. Because I feel like unless you have something that you contrast your interests with, you really do not know what is it that you like, right? So even in your field, if you want to find out like what is it that you really like, how do you quantify it? That this is the thing that you like. It's not it's just not because of that isolated exposure to that thing, but also because you were exposed to many different related things in the same discipline, but you were able to find out that this is something that stood out. So that's something that helped me understand that, okay, I'm not really interested in maybe front end development, but I would definitely like to do something with data and analytics and optimization and stuff like that. Yeah.
Gotcha. Well, Shubham, thank you so much for coming on.
Of course.
Really
Thank you so
appreciate
much
it.
for having me. Yeah.
Yeah. All the insights are really, really good, and I wish you the best.
Yeah, you too, man.
Thank you for listening to this episode with Shubham Pandey. I hope you learned something new and enjoyed your listening experience. If you'd like to listen to more episodes, you can check out our official website at www.heightsofhumanitypodcast.com. You can also find us on every major streaming platform. That includes Spotify, YouTube, Apple Podcasts, Amazon Music, Google Podcasts, and more. As always, thank you so much for listening. Have a great day.